Vacuum engineering is focused around industrial leak testing, and that is our core competency. We are a systems integrator and we understand the leak testing process. But what we have seen over recent years is that our customers want to increase the level of automation with the leak detection systems. So what we have done is we have set up VES automation, and effectively we are now able to supply full turnkey automated systems. Here we have a full cell where we do leak testing, we do robot sniff leak testing, and we do end-of-line testing, all managed by barcoding, traceability, and a robot. So what happens is the products are placed onto a trolley via a manipulator, and that trolley is then inserted into this letterbox here next to me. The robot will then automatically scan the product, so we have full traceability. From that point forward, the system will know the location that that part is in the cell, and it will also be able to record and share traceability data that is vital for the customer's system and knowledge base. So the robot picks up the component and it will then locate it firstly into the leak detection system. That is a tracer gas system. It is using helium as a tracer gas to locate very, very small leaks. In this particular application, the leak rate is 1 × 10⁻⁴ millibar litres per second. So the part will go into the vacuum chamber where it will conduct the vacuum test. On completion, the part will either pass or it will fail. If the fail is huge, i.e. there is a very large hole that you can see or you could hear air coming out if you compressed gas, you would then go directly into a failure bin, and an operator can then remove that part from the cell, and then it can be repaired and retested. If the fail is small, it will come out of the vacuum chamber and it will go directly to a robot sniffing cell, which is in the corner at the back of this system. On that cell we have a P3000Y sensor leak detector that is going to detect the location of the leak. It will still have helium tracer gas inside of the part, and the robot will basically track around the leak paths and look for the spike in the signal and be able to tell the system or the operators where that leak is so it can be repaired. When the leak is found, the part will then go back from there to the failure area as well, so it can leave the cell effectively. If the part is a pass, it will go directly to the end-of-line test, where we start by doing a low-pressure compressed air drying cycle. So for 50 minutes, we will flush the component with compressed air to remove any excess water vapor. After the 50-minute cycle, we then do a dew point test, and we check that the dew point is below -30°C. And if that is successful, we then complete a gas analysis and measure the oxygen content within the product itself. All of this data captured, stored, and sent to the central database for this customer. After the gas analysis, we then complete a high pressure flush test as a final kind of drying cycle before it's then taken from the end-of-line test and placed into the output trolley, where it can then go to the next stage in the production.